Rational exponents are exponents that are fractions. And so this little graphic up here shows us how we can translate an exponent that is in a fraction into radical form. So here's the things that you want to watch out for. The denominator of the fraction tells you what the index of your radical should be. And then the numerator of the fraction is the power that you raise that radical to. So they make two separate parts. So when you go to evaluate rational exponent expressions, it's typically easier to rewrite it in radical form. For example, 27 to the 3/2. The denominator tells me the index, and I'm taking this of 27. And then whatever we get, the numerator tells us what power to raise it to. The cube root of 27 is 3, because 3 to the 3rd is 27. And then we want to square that, so the answer we get is 9. You can try the other two if you want. So since the index here is a 2, it's going to be a square root of 9. Remember, if the index is 2, we don't write it. Blank right there implies that it's a square root, and then we raise that to the 3rd. Well, the square root of 9 is 3, and 3 to the 3rd is 27. On the last example, don't forget what your negative exponents do. These are going to make it the reciprocal, not a negative answer. It's going to flip it over. So this is going to be 1 over, let's go ahead and write out our radical, the 4th root of 81 to the 3rd power. So the 4th root of 81 is 3, and then when we take that to the 3rd, your answer is 1 over 27. Do not just put it in your calculator, because 1 over 27, it's going to give you 0.000 something, something, something. That's going to get marked wrong, because that doesn't show me that you know the rule. That just shows me that you know which buttons to push, which is great if this is all we were going to do, but you do have to know that concept of how this works out. Now, the properties of exponents work exactly the same, but when we have fractions, it gets a little bit trickier. So I always have sort of some scratch space off to the side where I can do the computations with fractions. So in this case, I am multiplying 5x to the 1/2 times 7x to the 3/4. 5 times 7 is going to give me 35. Then I'm multiplying x times x, so the base is going to stay x. But then I have to do, and this is where I do some work off to the side, since we're multiplying, we have to add fractions, 1/2 plus 3/4. Don't forget that when you add or subtract fractions, you have to have a common denominator. In this case, it's going to be 4. So I get 2/4 plus 3/4, which is 5/4. And so that tells us what the power of x should be, and that is our final answer. Adding and subtracting, you must have a common denominator. Multiplying, you just go straight across. So I'm going to put another example here off to the side. Let's say that I had a to the 1/2 to the 2/3. We don't find a common denominator here. You just multiply the numerators together and the denominators together. So we would get a to the 2/6, and then always reduce. So this would be a to the 1/3. Number 21 is an example where we have subtraction because we're dividing exponents. So I'm going to start. 32 divided by 16 gives me 2. Then I have to subtract 5/3 minus 3/4. The common denominator here is going to be 12. So times 4 times 4 times 3 times 3. So we have 20 over 12 minus 9 over 12, which is 11 over 12. So that tells us our x, 2x to the 11/12 power, and that's the solution.